All right, so we're going to go ahead and graph a line. We did the whole first page in class today, but if you don't need this, we're going to go ahead and just go over the graphing. You can go ahead and fast forward to the back page if you're missing the back page. All right, so let's go ahead and graph the line again. Y equals 1/2 x plus 4, so that is in slope-intercept form. So what I want you to do is I want you to write the slope-intercept form right underneath your equation so that you're able to identify your slope, which is 1/2, and your y-intercept, which is 4. Now understand that you're plotting your 0, 4, so that's x and y, and then you are going to move to your next point by doing rise over run. Rise over run. Now if it's positive, you're going to rise. So you're going to go up 1 and to the right 2. So going over here to the graph, you are going to plot 4. So you're going to go over here and you go up 1. You're going to, hold up, right here. You're going to go up 0 on the x and then 4 on the y. 1, 2, 3, 4. Okay, now you are going to do up 1 and over 2. So you're going to rise 1. So you're going to go up 1. And then over 2. So 1 and 2. That didn't come out right. Give me 1 second. You're going to go up. Let's see. You're going to go up 1 and then over 1 and 2, and you're going to plot your points. So here's my first point, and here's my second point right here. Up 1 and over 2. Draw your line in between your 2 points, and you are done. Okay? Now I'm going to go ahead and graph the y-intercept -3 and slope 2/3. Now my y-intercept is on the y-axis, so I'm going to go ahead and graph 0, -3, and then my slope is 2/3, so that again, that is rise over run. So I'm going to go rise 2 and run 3. So on my graph, I'm going to go ahead and plot 0, -3, 0 on the x, -3 on the y, 1, 2, 3, so right here. And then I'm going to use my slope and rise 2 and over 3. So I need to rise 2. 1, 2, and go over 3. 1, 2, and 3. So I'm right here. Rise 2 over 3. And you're going to go ahead and draw that line with arrows. All right. Now I'm going to graph a linear function that passes through the point. Again, you're given a point and a slope. It doesn't have to be the y-intercept. It could be any point. From that point, you can use your slope to get to your next point. But this is my point, x, y, 1, -4. And you're going to use your slope, 1, 4, to do rise over run. So you are going to plot 1, -4. So you're going to go over here, and you're going to plot 1, -4. So here's 1 on the x, and then you're going to go down to -4. So -1, -2, -3, -4, and it's 1, -4 is right here. So now you're going to use your slope. Your slope is 1 over 4. So that is rise over run. So I'm going to rise 1 and run 4. Now if it's negative, then you're going to fall, but we'll get into that in just a minute. So I'm going to rise 1 and run 4. So I'm going to go up 1, and I'm going to go over 1, 2, 3, and 4, and then plot your point, and then you're going to go ahead and draw that line right through my points, and I'm done. All it is plotting a point and using your slope to get to your next point. Now, let's go ahead and do this one before we get into the hard one. So this one is negative 3x plus 3. Y is equal to negative 3x plus 3. So when I write this, y equals negative 3x plus 3, this is your slope, this is your y-intercept. So slope is negative 3 and y-intercept is 3. I'm going to start at the y-intercept, 0, 3. And because this is negative 3, I need to make this rise over run. So the whole numbers go over 1. Now because this is negative, this is a falling line, not a rising line. So it's going to fall 3 for every 1. So run 1. So fall 3, run 1. So I'm going to go ahead and plot 0, 3, 0, 1, 2, 3. And I'm going to run, I'm sorry, that's my point. Now I'm going to fall 3, 1, 2, 3, and then I'm going to run 1. Go ahead and put a point right there. Now that's my x-intercept, by the way, because it's on the x-axis. Draw your line, and you are done with that. Hold on one second. Okay, so now we're going to go ahead and do the last one, and that is the megagraph. It's not the megagraph, but it's going from standard to slope-intercept. So this is not in slope-intercept form, but I can do this two ways. I can either solve for y and do it what we've been doing with the point and the slope, or I can just find my x-intercept and y-intercept. Now, knowing that when I'm on the x-axis, y is 0, I can make y 0 here and just do negative 4x equal to negative 12. Divide by negative 4, and x is 3. So if you know how to do it that way, then do it that way. But I'm going to go ahead and just... So what we're going to do is, first step is to add or subtract the x. And then your second step is to divide the number in front of y. So here's a negative 4x. So in order to move, I have to get this into y equals mx plus b. So this x has to come over here, and the y has to be by itself. So what do I do with the negative 4x? How do I get rid of it? With a positive 4x, because I have to add it. So I'm going to add 4x to both sides. Now, I cannot combine this x and this 12 right here because this is an x and this is a number, a constant. Those are not like terms. So this is just going to be a positive 4x minus 12. Okay, it's getting closer to y equals mx plus b, but now I have to get rid of the 6. So this is 6 times y. So what do? Divide 6, because that's the next step, is divide the number in front of y. So divide by 6, and y is equal to, now 4 divided by 6 will reduce down to 2/3 in your calculator, and 12 divided by 6 will reduce down to negative 2 in your calculator. Now that I have my y equals 2/3 x minus 2, I can go ahead and graph my y-intercept 0, negative 2, and I will use my slope to rise 2 and run 3. Rise 2 and run 3. So let's go ahead and graph that one. Go over here. I'm going to make my graph this time. And my y-intercept is negative 2. So I'm down here, negative 2. And I'm going to go up 2 and over 3. So I'm going to go up 2, 1, 2, and over 1, 2, 3. And I'm going to go ahead and plot that point. And this just so happens to be my x-intercept and my y-intercept. Now, if I had to keep going to get my x-intercept, then you have to keep going to get your x-intercept, because this problem asked for specific points. So please make sure that you are going to give me those specific points, x-intercept and y-intercept. So I got the y, because that's on the y-axis, right? But now I need this x, which is on the x-axis. So once I got my x-intercept, I can go ahead and draw the line in between those 2 points, and I'm done. So please, please, please make sure you know how to graph each of those equations. Now, those of y'all that are doing the assignment repair, please make sure that this is what you're supposed to do on that that one page, which is this page right here. That page right there. You got 5 graphs to graph for me, and I just want them on that page right there in different colors. Okay, let's go ahead and get to domain and range. Domain and range. Okay, so domain is my x, range is my y. All right, when you're looking at this right here, a continuous graph, you're looking at a range of numbers that my domain covers. So the domain is the set of all x values that my graph covers. So if you're looking at this, my x value starts at -4. And then it goes on and on forever because of this arrow. It doesn't stop. It's going to keep going on and on and on and on, and it's going to cover all of these x values. So everything greater than -4. Now the reason why I used greater than -4 is because this is not equal to. An open circle is not equal to. A closed circle is. So if this were colored in, then I would have a greater than or equal to. But my domain is all real numbers greater than -4. Or x is greater than -4. All right, now my range. My range is y, and y goes up and down. So now I'm looking at the lowest point to my highest point. Now, where does my graph start on the y? Well, my graph starts at -1, and it covers all of the y values going and going and going and going above -1. So again, my range is all real numbers greater than -1. So I can say y is greater than -1. So my range is y, my domain is x. All right, now looking at a discrete graph, it's a lot easier because all you have to do is just know what these points are. So this is -2, 1. This one is -1, -2. This is 0, 0. This is 1, -1. And this is 2, 1. So if my domain is all the x values, then I'm going to go ahead and give me all the x values. List out all the x values. -2, -1, 0, 1, and 2. Now range is the set of all the y values. So now I'm going to go on my right side of the point because the second number is my y's. So my y values are -2, -1, 0, and 1. And I'm done. All right, let's go ahead and move on to how to write an equation. So now I'm not graphing anymore. I am writing. You're okay. I'm not graphing anymore. I'm writing. So what do I need? I need my slope and I need my y-intercept. Now it's easy if I get a graph because I can see my y-intercept, and my y-intercept is 3. So I'm going to plug in 3 right here. But I need my slope, and you can do slope 2 ways. You can use your rise over run, but in this case it's falling, so it's going to be fall over run. So my slope is fall over 1. Well, how much do I fall? Well, I fall 1, 2 over 1, 2, 3. So I fall 2 and I run 3. So that's going to be a negative 2/3. Now that's the easiest way to come up with your equation, negative 2/3 x plus 3. I will put that in Desmos or the calculator and make sure that that is my line. But how would I find slope if I didn't want to count? You have to use your slope formula. So the slope is equal to y2 minus y1 over x2 minus x1. So my first point is 0, 3, and my second point is 3, 1. Okay, so when I'm using this formula, I'm going to go ahead and use my y's. So my y's are 3 and 1. So I'm going to do either 3 minus 1 or 1 minus 3. It doesn't matter. Let's go ahead and do 1 minus 3. Okay, on the bottom you're going to start with that same point, but this time you're going to have x's, so 3 minus 0. What is 1 minus 3? Negative 2. What is 3 minus 0? 3. And my slope is negative 2/3, and that's how we got our slope. So when you're writing an equation, just make sure that you find your slope and you find your y-intercept, and once you do those two things, put it in your equation, because your equation is your answer. Not your slope, not your y-intercept, but them together. Okay, y equals mx plus b. All right, let's go ahead and move to the back side. Can you write an equation given a table? Now I'm going to tell you right now that your table that you're always going to get is not going to have your y-intercept. They want to make sure that you know how to actually find your y-intercept. Now, when we get into linear regression, Desmos is going to make this a lot easier, but we're not there yet. So I need to see your work on how to find this by hand, okay? Using strictly math, straight math. So in order to find my equation, I need 2 points. So I'm going to use this point, and in class we used this point down here. Y'all wanted to use that one, so I'm going to go ahead and use this one. This one and this one. You could have used this one and this one, it's fine. All right, so I have negative 4, 5, and I have 3, negative 16. My slope is the change of y's over the change of x's. So my y's are here, my x's are here. So I'm going to do negative 16 minus 5, 3 minus a negative 4. Negative 16 minus 5 is negative 21. 3 plus a negative 4, that'll turn into a plus, so that is a positive 7. So this is negative 3. Found my slope, I need to find my y-intercept, so I need to use a point. So pick a point. Any point. Let's go ahead and use this one again. So this is going to be my x, this is going to be my y. So this is the point that I'm going to choose. So I'm going to do y equals mx plus b. The y in the point that I chose is negative 16. The slope that I just found is negative 3. The x in my point is 3, and it's plus b. What is negative 3 times 3? Negative 9 plus b. How do you get rid of a negative 9? You add 9 to both sides, and b is equal to negative 7. Now again, here's my slope, here's my y-intercept, but my answer is y equals negative 3x minus 7, and that's my answer. Now I'm going to go ahead and write an equation of a line that passes through this point and is parallel to this equation. All right, so parallel, you need to know that it's same slope. Same slope. So if it says parallel, write same slope. When they give you a point, that's your x and your y. Now the only thing you're missing is your slope. They give you something to reference. They give you another line here. But I can't see nothing from that line because it's not in y equals mx plus b form. So again, you're going to have to take the standard form of the line and change it to solve for y. So the first step again is to add or subtract your x. So this time I'm going to subtract 3x to the other side. Then I have negative 3y equal to negative 3x plus 6. And the second step is to divide the number in front of y, so divide by negative 3. When you divide by negative 3, this goes away, it's 1. 1 times y is y. Then this is 1x, and this is minus 3. Now instead of 3, 1, I'm going to change this to 4, 1 because we had problems in class with this one. So let's go ahead and change that point to 4, 1. So now my x is 4, my y is 1. To be parallel, I have the same slope. So my slope is also going to be 1. Because the slope in this line is 1, and if I'm parallel, then I'm also going to have the same slope. So I have a slope of 1. Now how do I find my b? I'm going to do y equals mx plus b. The y in my point is 1. The slope, my parallel slope is 1, and the x in my point is 4. 4 times 1 is 4. 1 is equal to 4 plus b. How do you find b? You subtract 4 to both sides, and b is equal to negative 3. So I'm going to plug in negative 3 here. My answer is y equal to 1x minus 3. This point, this line is parallel to this line. What? Actually, it's the same line, but just kidding. This right here is 6. Just kidding. 6 divided by negative 3 is negative 2. Okay, sorry, not the same. Not the same. This one's x minus 2, and mine is x minus 3. So yes, they are parallel because they have the same slope. All right, yes. Okay, what if I give you a graph? Okay, and it says, what is the equation in slope-intercept form of the line that passes through the point 3, 6 and is perpendicular to this line in this graph? All right, so my point again is x and y, so that's my point. But I'm perpendicular. Perpendicular means that I'm going to, 1, have an opposite, my slope is going to have an opposite sign. And 2, I'm going to be the reciprocal of this slope. So the first thing I'm going to do is figure out the slope of this line. So I need 2 points. This is a point, and this is a point, and this is a point. So if I wanted the equation of this line, I know that my y-intercept is negative 5, and for every, when I do rise over run, I go up 3 and over 1, up 3 over 1. So when I go up 3, that's 3 over 1. 3 divided by 1 is 3, so it's 3x. Up 3 over 1 is 3. That's my slope. Now again, if you don't want to do that, this is 0, negative 5. This is 2, negative 2. this is 2, 1. No, I'm sorry. That's 1, negative 2. And this is 2, 1. So you can use any of those any 2 points of those and find slope, and when you do that, you get 3. So if I do that, I get, let's see, negative 2 minus 1 and 1 minus 2. This will give you negative 3 on the top. This will give you negative 1 on the bottom. And when you do negative 3 divided by negative 1, you get 3. So there it is, 3x. Now that's my slope. But if I want perpendicular slope, I have to change it. So my perpendicular slope is going to be a negative, because this is positive. And now I have to flip this 3 over 1 around, which is 1 over 3. So this is my slope. This is my point. Solve for b by plugging it into y equals mx plus b. So what's my y and my point? 6. What's my slope that I just found? Negative 1/3. What is my x and my point? 3. 3 times negative 1/3 in your calculator is going to give you negative 1. And how do you solve for b? You add 1 to both sides. When you do that, b is equal to 7. So now I have my y-intercept, now I have my slope, now put it into y equals negative 1/3 x plus 7. And that is my perpendicular line to the line that is graphed. So let's see what this looks like. I'm curious. So if I plot 7, let's see, this is 5. I'm 1, 2, 3, 4, 5, 6, 7. And then I'm going down 1 over 3. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3. So if this line goes up and my line goes like this, there's my t. Right there. There's my perpendicular line. Okay? All right. Anywho, that is my equation, y equals negative 1/3 x plus 7. So, right, that is like the mega problem right there. This one and this one. These are my mega problems because it requires you to know what parallel is, and it requires you to know what perpendicular is. You have to find your slope, and then you have to go and find you have to change your slope if it's perpendicular, and then you have to go and find your y-intercept, and then piece everything together. So is it long? Yes. But do you understand it? You should be. You should be able to understand it. Now, you will be able to use this on your test tomorrow, so make sure you write it down. Okay, write an equation that is parallel to the x-axis. Parallel to the x-axis. So first, what does the x-axis look like? Right here. Boom, x-axis. Parallel to the x-axis would be another horizontal line. So we were going over in class Hoy and Vux. Hoy is that for every horizontal line, because I don't have a rise, then my slope is equal to 0. And my equation is going to be y equals a number, which is the y and your point. Now, here, Vux is vertical and slope is undefined. That means that I don't have a run. So you can't divide by 0. So this is undefined. And my equation is going to look like x equals a number. So it's going to be a vertical line, a vertical drop. Okay, vertical line. So here it says parallel. Well, you know what parallel lines look like. They look like the same direction, right? Same horizontal, horizontal, vertical, vertical. It looks like this, okay? It looks like your L's in parallel, or like this, or like this. Perpendicular lines cross at a T, okay? Now, so this is a horizontal line. So horizontal line, 0 slope, and y equals 3. Now, if they would have said perpendicular to the x-axis, perpendicular would be a vertical line, and that would be an x equals equation, and that would be x equals -5. All right, now, let's go ahead and finish this off. This right here is a vertical line, so now you're dealing with VUX. So let's go ahead and describe this graph. This is VUX, a vertical line. Vertical line, slope is undefined. My equation is x equal to, well, where does it cross? 3. X equals 3. Parallel will be the y-axis. Parallel will be this y-axis, which is x equals 0. Perpendicular is the x-axis to this line. Okay, so my line, if you can't see it, my line is here. Okay, so perpendicular to that line would be the x-axis. Okay, so because it's the complete opposite, and it crosses at a 90-degree angle. So this would be the x-axis, and the x-axis is a horizontal line at y equal to and then 0. So any y equals horizontal line, y equals 1, 2, 3, 4, 5, any of these numbers right here, y equals will be perpendicular to this vertical line. Okay, any x equals, apart from x equals 3, will be parallel to this vertical line. Okay, well, make sure that you have this filled out front and back before you come into class tomorrow, and you'll be able to redo your test for full credit. All right, good luck tomorrow. I believe in y'all. Y'all got